All right, hello and welcome. Today we are going to untangle the wild world of network communication. We're going to build a kind of mental map for how it all actually works, and we're going to do it using this really powerful framework called the OSI model.
You've heard all these terms flying around, right? IP addresses, packets, TCP, routing. It can feel like a big, jumbled mess of puzzle pieces that don't quite fit together. But what if I told you there's a master blueprint that makes sense of it all?
Well, guess what? There is. Meet the OSI model. Seriously, think of this thing as the ultimate organizational chart for how networks talk to each other. It's a framework that takes the huge, super complex job of sending data and breaks it down into 7 clean, logical, manageable layers.
So how in the world do we make sense of these 7 layers? We're going to use a really simple, but honestly a really powerful analogy. We're going to think about a huge international company. For that company to work, it needs different departments, right? And each one has a very, very specific job to do.
Okay, this slide right here, this is our roadmap for the whole explainer. On the left, you've got the company departments, from the CEO all the way down to the physical roads. And on the right, you've got the OSI layer that matches up with it. You're going to see how each department's job maps perfectly to what each layer does. Let's dive in.
So, let's do this. We're going to follow a single message on its incredible journey, starting way up at the top with you, the user, and following it all the way down to the actual physical wires and radio waves that carry it across the planet.
Our journey kicks off at the very top, layer 7, the application layer. Now this is the one you and I actually see and touch every single day. When you pop open a web browser, shoot off an email, or jump into an online game, you are working directly with the application layer. It's the bridge between your software and the network itself. In our company analogy, this is the CEO. The CEO doesn't get bogged down in the details of how a message gets delivered. They just make that big, high-level decision. I want to send an email. That's it. This layer starts the whole process.
Right below the application layer is layer 6, the presentation layer. You can think of this as the company's master translator. Its whole job is to make sure that the data sent from your computer is in a language that the computer on the other end can actually understand. It handles stuff like encryption to keep it secret, compression to make it smaller, and formatting it into a standard type, like a JPEG image.
And this fits perfectly with the CEO's super organized secretary. The secretary takes the big idea, writes it down clearly, makes sure it's in the right language, and then puts it into a secure, tamper-proof envelope before it goes anywhere else.
Okay, so the message is perfectly formatted. Now what? We have to actually manage the conversation. And that's the job of layer 5, the session layer. It's in charge of opening up a communication channel, keeping that channel open for as long as it's needed, and then closing it down cleanly when you're done. You know, like when you log into your bank account? The session layer keeps you connected securely and then logs you out if you're inactive.
In our company, this is the manager. They set up the meeting, they lay out the ground rules for the conversation, and they decide when that meeting is officially over. They just make sure the whole dialogue is orderly and controlled.
Now we're down to layer 4, the transport layer. And listen, this one is absolutely crucial. This layer is all about reliability and quality control for the entire journey. It takes big chunks of data from the layers above and breaks them into smaller, numbered pieces called segments. It uses super reliable protocols like TCP to make sure every single piece gets to the destination and that they all get put back together in the right order.
Our company's transport department is the perfect analogy here. I mean, they wouldn't try to ship a giant encyclopedia in one massive, flimsy box, right? No way. They'd break it down into numbered volumes. That makes it easy to track, and it ensures that if one volume gets lost, they know exactly which one they need to send again.
Welcome to layer 3, the network layer. This is the master navigator of the internet, the GPS for your data. It does 2 main things. First, it stamps those data segments with IP addresses, where it's from and where it's going, turning them into what we call packets. And second, it figures out the best possible path for that packet to travel across the entire internet. This is where routers do their magic.
So in our company, this is the mailroom. They take those numbered volumes from the transport department, put them in packages, and slap a label on each one with the full sender's address and the final destination address. Simple as that.
Next up, layer 2, the data link layer. Now, pay attention here. While the network layer is thinking about the entire trip from, say, New York to Tokyo, this layer is only focused on the very next stop. It handles the data transfer between two devices that are directly connected on the same local network. It uses hardware addresses, called MAC addresses, to get the job done, turning packets into what we call frames.
And this is our delivery driver. The driver isn't worried about the final address in Tokyo. Nope. Their only job is to get this truck safely from this warehouse to the very next distribution center, or from this one intersection to the next. They just handle one single hop at a time.
And finally, we've reached the bottom. Layer 1, the physical layer. This is where all that digital data becomes real, tangible stuff. This layer takes those frames and turns them into actual physical signals that travel across the network. We're talking electrical pulses in an Ethernet cable, flashes of light in a fiber optic cable, or radio waves for your Wi-Fi. It's all about the hardware.
In our company analogy, this is the infrastructure itself. It's the roads the truck drives on, the truck itself, the fuel in the tank, all the physical things that make the transportation of that package even possible. Without this layer, nothing is going anywhere.
So we've seen how each layer has its own very specific job. But how does the data itself get prepared for this trip down the stack? Well, there's a process for that, and it's called encapsulation.
This shows it perfectly. Your data starts up at the top. As it moves down through each layer, a new header gets added. Kind of like putting a letter in an envelope, then putting that envelope into a small box, then putting that box into a bigger shipping container. By the time it hits the wire as raw bits, it's all packaged up and ready for its long journey.
But look, this model isn't just some abstract theory for a textbook. It's an incredibly practical tool for solving real-world problems. It gives network engineers a logical, step-by-step way to figure out what's gone wrong.
Let me give you an example. Let's say a website won't open, but you know your other internet stuff is working just fine. Using the OSI model, you can start to reason it out. You can say, well, my cable is plugged in, so layer 1, the physical layer, is probably okay. I have an IP address, so layer 3, the network layer, is working. And that lets you logically figure out that the problem is probably way up high, maybe at the application layer with your browser.
So here's the bottom line. The OSI model takes network chaos and turns it into a structured, understandable system. It gives you a whole new way to see how our digital world is all connected. So the next time you run into a network problem, you won't just see a random error message, you'll see a puzzle with 7 distinct pieces. The question is, which piece are you going to check first?